Hi, my dear. Uncle Demi. Here I am. Part C. Tube water wall. Tube wall is a small diameter hole drilled on a deep depth in the subsoil formation, while a suitable diameter tube with perforation portion at a suitable depth should be immersed inside. A straining device should be used in the space between the inside tube and walls of the outside hole to prevent the clogging processes and consequently increasing the efficiency of the side wall. The tube wall may be go down more than 100 meters inside the aquifer, which is confined or unconfined, and its average discharge is almost around 100 up to 150 cubic meters per hour, except in some cases, which have high discharge around 300 cubic meters per hour. Generally, there are three types of tube walls, such as strainer, cavity, and slotted walls. Strainer tube wall. It is the most common and widely used. In addition, there's a term of expression tube wall refers to this type of wall. In this type, a strainer, which is a special of wire mesh, should be wrapped around the perforation part of the tube in front of the carrier layer only, while the rest portion tube are keeping a solid wall blind. Generally, the tube should be fixed vertically at its top, and all short lengths of pipe should be settled with a curved flap at the bottom, which works as a trap for any fine particles which may be passing through the strainer portion, as illustrated in the enclosed figure. Figure showing the strainer tube wall. Look, my dear, to the blind parts and the strainer part. Cavity tube wall. In this type, water contribution to the borehole through the bottom layer only. It derives water from a permeable layer underlying a hard impermeable one. Therefore, the blind tube at this type should be go down till penetrating an interior layer aquifer and reaching to a good water bearing layer aquifer. The main difference between the strainer and cavity tube walls are that the inflow of water has a radial pattern in the former one, as it enters the tube through the long wide straining part only, while it has a spherical pattern in the latter one, as it enters the tube from the bottom only through the formulated cavity, as illustrated in the enclosed figure. Figure showing the cavity tube wall. My dear, look to the formed cavity at the bottom of this one. Slotted tube wall. This type is preferable to use when neither sufficient depth of aquifer nor a suitable impermeable layer as strong roof are available. A slotted tube has 160 up to 200 mm diameter, has a suitable length, slotting with the plug at its lower end, while the rest upper portion should be kept solid, flat, and commonly each slot has 2 by 2 cm dimensions and 1 cm in between each other. This slotted tube should be going down in the aquifer and shrouding by using a suitable envelope of gravel with coarse sand, as illustrated in the enclosed figure. Figure showing the slotted tube wall. Look, my dear, to the slotting portion at the lower end of wall, surrounded by gravel and coarse sand. Construction of tube wall work. During operation, including sinking an outer hole, casing until penetrating the required second. This casing should be complete vertically downward direction and has a little more diameter than the tip one. Selection of the suitable drilling method in any site depends on the underground layers formation depth of groundwater, purpose of irrigation water, required discharge, and the availability of equipment. Generally, the most common method of being are wash pouring or water jet, percussion or couple tool, hydraulic rotary, and reverse rotary, and so on. Water jet method. This method, which forms known as water method, is more suitable in sites where the soil layer forming of gravel, sand, or clay particles. An outer two-hole casing should be erected first and settled inside a pit on the surface. Downwarding a case tube by sinking it gradually and vertically also inside the soil, and using jet pipe with nozzle inside the casing tube and forcing water under high pressure through it. Consequently, the sludging of soil particles should be lifted up from the annular space between the casing and jet pipe. The casing pipe should be rotating slightly, and so sinking will occur gradually in the loosened soil until reaching the desired depth. Accordingly, the well tube with its screen should be lowered inside the outer casing, and then starting to pulling out the casing tube gradually, filling the annular space with unsuitable envelope material, while keeping the well tube on vertically position and fixing it at its upper portion by using a stabilizer pavement. Percussion method. This method depends on pricking and polarizing the subsoil formation by repeating block with cutter. Generally, the pouring can be done manually or machinery. The manually percussion can be done by following some procedures as shown in front of you, my dear. Follow it by yourself, it is so clear. The manual percussion is so clear as illustrated in the enclosed figure, while sometimes, if the soil formation is so hard, and in case of desiring a more deep well, in addition to faster the drilling rate, it is preferable to do the percussion process mechanically, which is known as cable tool method. This machinery method can be done by using a driller, as illustrated in the enclosed figure. Figure showing both manual and machinery percussion methods. Look by yourself, my dear, and know the difference. Figure showing the drilling machine or percussion method with its drum. Hydraulic rotary method. This method is known as the rotary pouring method, and generally used successfully in hard and rock soil, and therefore it is used also for digging the oil wells. Generally, the hydraulic rotary drillers consist of direct rotating cable, drill pipe with pit, injection mud pump, hose, and engine. The drill pipe is stainless steel available in 6-meter length and 2 up 4 inches diameter, connected by a pin with non-return nozzle at its lower end and a steel rod carried at its upper head, which fixes it to the rotating cable on the surface. The rotating cable gets its movement power from the engine, which causing the turning of drill pipe, and accordingly the bit starting for cutting the subsoil formation gradually, and so the hole should be deepened more, and consequently the kelly should be unfastened and pulling up to attach a new length of drill pipe. The drilling fluid or bentonite slurry sometimes should be pushing by using a mud pump through the drill pipe down and through the nozzle out. Then, the slurry mud should be raised up to the soil surface through the annular space between the drilling pipe and poor walls, removing the rock fragments at the same time as shown in the illustrated figure. Figure showing and explaining the hydraulic rotary method. Even the poor walls are coated by bentonite, should be necessary to wash it. Accordingly, the process of backwashing should be done by inserting the drill pipe with a collar again carefully inside the well pipe and starting to push water with collogon sodium hexametaphosphate through the drill pipe as shown in the enclosed figure. Reverse rotary method. It is similar to the hydraulic rotary method, but reversing the flow of drain fluid from down to up, and for this reason it gets its name as reverse method. Therefore, the driller using in this way is similar to the fuse in rotary pouring method, except has a large drill pipe diameter to be enabled to passing the polarization subsoil formation up, and also have a special large capacity of pump with rotary blade. Water with slurry mud only are using as a drilling fluid, which moving down into the poor hole through the annular space between the drilling pipe and poor wall. The rising fluid should have a large velocity for causing lifting of the big size fragments and so on, as shown in the illustrated figure. Figure showing and explaining the reverse rotary method. Design of tube water well. Selection of the suitable site for erection a tube well is very important to achieve the maximum efficiency of using the underground water reservoir. Water samples should be sent to the laboratory to check up its quality. Drainer tube wells is the most commonly type used and practiced one. The soil samples presenting the different layers should be collected and arrangement on the soil surface during the progress of drilling operations. Furlong. Accordingly, a right decision should be getting for achieving the right erection, such as depth and diameter of well casing, depth of aquifer, length, type and size of straining portion, and shrouding and size of envelope material. The suction pump should be fixed in the right position inside the tube well, and it should be first under the dynamic level and second in front of drain. Development of tube water wells. It is an important to do a development process for erection a tube well before using it, as this operation has many advantages which can be followed up by yourself, my dear. The rest of development process operations follow up, my dear, by yourself. It is so easy. Yield of tube water well. Normally, a cone of depression will be formed around the well after pumping water from it, and the drop in water level is known as drawdown or depression head, as explained before. Accordingly, calculation of critical discharge of tube well is not easy. However, scientists simplify this problem basing on Darcy's equation by assuming some conditions which are written in front of you, my dear. Therefore, the charge of tube well installed in an unconfined aquifer can be calculated by a formula as shown in the enclosed equation. While a case of installing well in confined aquifer can be calculated by a formula as shown in the enclosed equation, with the parameters of both equations as you see. Jet flow method for estimating discharge of water wells. Really, this method provides a simple practical method for estimating flow from both horizontal and inclined pipes, especially for field investigation and tests. As follow in front of you, my dear. Follow it by yourself, which clear by the enclosed figure. Figure showing the nomograph of estimated discharge Karez, which will be used, my dear, after measuring the horizontal projection X as clear before. Table showing the charge correction factor, referring to the percent of freeboard to the outlet inner diameter, IT. Generally, measurement can be obtained by using this approximated practical method as clear before at several conditions such as the most accurate estimated discharge will be obtained when the charge is constant. The outlet pipe should be straight after the nearest elbow or bend by at least 1.5 meter long. Estimated discharge will be so high if the outlet pipe inclination upward and being too lower when the outlet pipe be downward, and measuring of both perimeters X and Y must be done accurately, otherwise we will get non-exactly data. Moreover, discharge can be measured from a vertical oriented pipe flow by using the enclosed equation and figure as clear in front of you, my dear. Infiltration galleries and horizontal water wells. Sometimes, when there is no possible for obtaining a sufficient quantity of water from an open vertical well, and if the site conditions are suitable, an infiltration gallery or tunnel can be constructed in a favorable area to transmit water to the desired location. Infiltration gallery is a porous pipe connecting each other and laid under the ground surface at a suitable moderate depth parallel to a river bank to intercepting the groundwater gradient flow, which can be collected in a vertical collection pipe or reservoir. This porous pipe should be coated by a suitable envelope material to alleviate the clogging pressure, as shown in the enclosed figure. Figure showing infiltration wall and collecting water mechanism from an embedded river ephemeral by embedding many infiltration galleries under its bed and joined by using an infiltration gallery to a reservoir or main collecting well known as jack well, installed in the middle distance of river bank. Moreover, there is another way which is known as Karez system and successfully used for collecting water from under the house. Generally, the charge of Karez system depends upon its penetrating length in the aquifer and its receiving discharge, as shown in the enclosed figure. Advantage and disadvantage of using water wells for irrigation. Really, there are many advantages and also disadvantages of using water wells for irrigation. Follow it by yourself, my dear, it is so easy. There is no advantage and disadvantage of using water wells for irrigation, my dear. Construction of water wells in soils affected soil. Indeed, it is preferable to follow some procedures on construction water wells for irrigation purposes in soils affected soil. As shown in front of you, my dear, follow up. It is so easy and clear. There is a procedure of construction water wells in soils affected soil. Goodbye.